At this point, we'll move on to some other examples, but first I wanted to explain one of the most important concepts in the topic of sampling distributions. This concept is called the central limit theorem. The central limit theorem allows us to predict the shape of a sampling distribution of sample means without having to actually create the sampling distribution. In other words, the central limit theorem allows us to predict the shape of a sampling distribution without having to actually calculate the mean of every possible sample that could be selected. According to the central limit theorem, the shape of a sampling distribution of sample means is predictable based on the shape of the population and the sample size. The central limit theorem makes two important points. First, it says that if the population that's being sampled is normal, the sampling distribution will always be normal. In other words, if you're selecting a sample from a population that follows a normal distribution, then the means of the possible samples that could be selected will always follow a normal distribution. The second point that the central limit theorem makes is that if the population is not normal, if the population is skewed, then the sampling distribution will be skewed just like the population if a small sample is being selected, but the sampling distribution will be roughly normal if a large sample is being selected. In this case, large means generally 30 or larger. This concept might seem a little bit abstract and difficult to understand at first, but I'll show you a website that I think will make this concept a little bit more clear.